Welcome to Lecture 2.7, Multiplication and Division with Mixed Numbers. Now this topic may sound a little confusing, but really the only thing that we're going to do differently between mixed numbers and fractions when we multiply and divide is we need to change it to an improper fraction first. So to multiply or divide mixed numbers, first we change it to an improper fraction, then we proceed like regular steps of multiplying or dividing fractions. So for example, multiplying 2 3/4 and 3 1/5. First step, change to improper fraction. So let's take each fraction and change it over to an improper fraction. So 4 times 2 plus 3 all over 4 is going to be the process. So 2 times 4 is 8 plus 3 is 11 all over the original denominator. Again, it's the denominator times the whole number plus the numerator will give us our new numerator. And our denominator of the old fraction is still our denominator of this fraction. Let's try it one more time. 3 1/5, that's 5 times 3 plus 1 will give us 16 over 5. Now that I have my improper fractions, all I need to do is multiply all the numerators, multiply all the denominators, and I am done. Well, somewhat. But done with multiplying the fractions at least. So let's take a look at our numbers here and see, with 11 times 16 over 4 times 5, can I reduce anything? Well, the 16 is 4 times 4, so I can reduce one of the 4's on the top and the 1 4 that's in the denominator. Now I have 11 times 4 is 44 all over 5. But remember what type of numbers I started with. I started with mixed numbers. So the last step is to rewrite my result using mixed number notation. So you take the denominator, multiply it into the numerator, so 5 divided into 44 goes 8 times with a remainder of 4. So you put your remainder over your divisor. So it is 8 4/5. Let's try one more problem. Let's multiply 3 and 4 5/8. So again, first step is to change to an improper fraction. Well, 3 is just 3 over 1. And then 4 and 5/8 is going to be 8 times 4 plus 5. So 32 plus 5 is 37 all over our original denominator of 8. So now we multiply our 2. We multiply our numerators, we multiply our denominators. So 3 times 37 all over 1 times 8, which is 8. So 111 over 8. But again, I started with mixed numbers, so I better go back to mixed numbers. So 8 goes into 111 13 times with 7 remaining. So 13 with 7/8. Now let's try our hand in dividing. So again, the steps are exactly the same as it was before, except the extra step of converting our mixed number into an improper fraction. And of course, the final step is I want to make sure that I go back to mixed number notation. So let's divide 1 3/5 with 2 4 4/5. So 1 3/5, let's convert. 5 times 1 is 5 plus 3 is 8, so it's 8/5. 2 4/5 will be 5 times 2 is 10 plus 4 is 14 all over our original denominator of 5. Now with division of fractions, my second step of division of fraction is to rewrite it as a multiplication problem. But not just, exchange the division for multiplication. I need to multiply by the reciprocal. So if I multiply the 8/5 by the reciprocal of 14/5, it will be 8/5 times 5/14. Multiply the top, the numerators, multiply the denominators. And again, I'm going to break it down as much as I can, or as much as I need to be able to cancel some of these terms out. So an 8 is a 2 times 4. 5 is just 5, it's prime. 5 times 14, well 5 is prime, but 14 can be written as 2 times 7. So I have a 2 on the numerator, 2 in the denominator, a 5 in the numerator, a 5 in the denominator. So therefore it is 2 times 5, and 2 times 5, 10 over 10 is 1. So I'm left with 4 in the numerator and 7 in the denominator. How about 5 9/10 and 2? Well, let's convert our 5 and 9/10. 10 times 5 is 50, plus 9 is 59 over 10. 2 is just 2 over 1. Now we're going to write it as a division problem. But again, I don't want a division problem. I want to change it to multiplication by the reciprocal. And the reciprocal of 2 over 1 is 1 over 2, or 1/2. So multiply the numerators, multiply the denominators. 59 times 1 is 59. 10 times 2 is 20. And no, I can't reduce that. All right, so let me work one out step by step. So the first thing I want to do, again, is to convert my mixed number notation over to an improper fraction. So 3 1/5 is going to equal 3 times 5 plus 1 all over 5. 3 times 5 is 15 plus 1 all over 5. And my improper fraction is 16/5. Let's try 4 1/2. Multiply the denominator and the whole number, 4 times 2, plus the numerator, all over the original denominator. 4 times 2 is 8, plus 1, all over 2. 9, 8 plus 1 is 9, all over 2. And now my problem is 16 over 5 divided by 9 over 2. But again, with fractions, I don't want a division problem, so I'm going to say 16/5 times the reciprocal of 9/2, which is 2/9. Multiply the numerators, multiply the denominators. So it will be 32 all over 45. Okay. Now let's try something a little bit more complex. Okay. This looks a little bit more difficult, but we'll take it step by step. So my first fraction is already a fraction, 3/4, divided by 2 1/2. Well, 2 times 2 is 4, plus 1 will be 5/2, divided by 3 over 1. All right, let's take care of the parentheses first. You have to remember your order of operation. 3/4 times the reciprocal of 5/2, which is 2/5, all divided by 3 over 1. Okay. I'm going to go ahead and do the multiplication. Well, I do see 3 times 2 over 2 times 2 times 5 divided by 3 over 1. I can reduce. So my new problem is 3 over 10 divided by 3 over 1. Again, I want to change my division to a multiplication problem. So 3/10 times the reciprocal of 3 over 1, 1 over 3. Oh, lucky me. 3 times 1 over 10 times 3, I can reduce. So my final solution is 1/10. Now you do have to stop and think, is this an improper fraction? If it is, I need to change it back to mixed number notation. But this is not. This is a proper fraction, and I can leave it as is. Let's take a look at this problem. There's a lot of information on the screen, so let me just run through it really quick. I have 2 brands of canned tomatoes, let's say. The serving size of each is 1/2 cup. The servings per can is 3.5 servings per can. And then I have some information about per servings. First one is calories. So the first brand is 45 calories per serving, whereas the second brand is 25 calories per serving. They both don't have any calories from fat. Sugars, the first brand has 9 grams, the second brand has 4 grams. Sodium, first brand, 560 milligrams, and the second brand, 300 milligrams. Dietary fiber, the first brand has 2 grams, whereas the second brand has 1. And protein in each is 1 gram. So we want to compare the total number of calories. Okay? We want to compare the total amount of sodium. We want to compare the total amount of sugars and the total amount of proteins. So let's set this problem up. Alright, so I want to compare the total number of calories in the whole entire can. So in can, and I'm just going to do a little table down here, in brand number 1 and in brand number 2. Total calories. Okay. They both have 3.5 servings per can. So in brand 1, it's going to be 45 times 3.5, but let's change that to an improper fraction. 2 times 3 is 6, plus 1 is 7. 45 times 7 over 2. And brand 2 is 25 calories times, again, 3.5 is going to be 3 times 2 plus 1 all over 2, which is 7 halves. 45 times 7, so that's 315 over 2, and 25 times 7 is 175 all over 2. But let's change it into a mixed fraction. 2 goes into 175. Let's see, that would be 8 and 7 and 1/2, the remaining. And then 2 goes into 315, 2 goes into 3 once, with 1 remaining, so 2 goes into 11, 5 times, 1 remaining. 2 goes into 15, 7 times with 1 remaining. So the calories, I can compare 157.5 per can to 87.5 per can. Let's try sodium. So again, whatever the sodium is, I'm going to multiply it by 7 halves. So I have 560 milligrams times 7 halves. And I have 300 milligrams times 7 halves. Well, I know 2 goes into both of these, into the 560 as well as 300. 2 goes into 300 150 times. 150 times 7 is going to be 1,050 milligrams versus 2 goes into 560 280 times. 7 times 280 is 1960 milligrams. So I'm going to let you do the rest on your own, follow the same procedure. So until next time, be seeing you.